architect with Microsoft is my day job, and my hobby, if you will, is being the lead for the Houston Azure user group, which I've been lead for around 6 years now. And you are you're attending or watching the recording of the May 2021 edition of our Azure Meetup. This one is going to be quite an interesting one, a problem that many of us have dealt with in some form or another, and we're seeing it more and more, the need to further secure services in Azure. And of course, most very common with IaaS, but seeing that more and more with the platform as a service components of Azure. So a little bit about the group, and so what we're about before I introduce our speaker, Sergio. So for anyone new, coming at you live from Katy, Texas. I've got a few folks. Sergio's in Brookshire, and we have some other folks. We have some Sugar Land folks, some other Katy members. Greetings, everybody from everyone in Houston. Is there anyone who's not in Houston who's joining us? We've had a few folks. You can either speak it out or drop it in the chat. That'd be kind of cool. We had someone from Stockholm a couple of months ago, so that was cool. So if we're not from Houston, then we'd love to know that. Andrew's typing something. Okay, okay. Perth, Western Australia. Really? Oh. Wow. Okay, that's cool. Greetings from Houston, Andrew. Yeah, thank you for joining us. A warm welcome. So, okay, that's one of the benefits of us being virtual. We've normally had in-person meetups for the last 6 years or so here in town. So it's quite fun to be virtual as a result of COVID. But we will be back in person at some point. But perhaps we'll continue also being virtual. And actually, this is one potential reason why. I mean, spread the love a little bit. We have interest from around the world. So that's a good thing. And some of our topics certainly are very, very interesting, and we've had some good ones over the years. I think this will be no exception. But anyway, so the focus of this group is about community, about learning from one another. We have had presentations and discussions from folks who are experienced users of Azure at companies and consultancies, and sort of either large or small, from large and small companies here in Houston, and sometimes from Microsoft folks who are in a similar role to myself, like cloud architect, or from engineering teams, speaking about various services and capabilities of the Azure platform. The intent is more of a discussion, really. It's about learning. Everyone's here to learn. So if you're looking for a sales pitch, this is the wrong place. This is not what this is about.
Wrong session.
Yeah, wrong session. Yeah, not going to be doing that. So if you've got questions around pricing and maybe how it compares to AWS and can you get a deal, this is not the right place for that. If, however, you want to learn, some of the brutal realities about how things actually, if you're really truly implementing something on Azure, you've got a problem you're really looking to solve, and you're trying to get behind maybe the documentation and learn how it's really done and what can be learned from that, or maybe the lessons learned from others, you're in the right place. Here in Houston, we have a lot of folks from oil and gas, a lot of large companies, enterprise customers, large IT departments, and so using the whole breadth of the Azure platform. So there is probably not a problem that hasn't been encountered by someone at one of these enterprise customers, and a challenge encountered, and therefore we see quite often a potential shared lesson learned. So there's something I think to be learned from everyone. So oil and gas, we have a lot of healthcare folks. We have some finance folks, and that has some interesting ramifications from a regulatory compliance perspective, like the healthcare folks who join us as well. We have a lot of quite a number of software companies, and also focusing on a variety, not necessarily, but also including oil and gas. They also have some similar and interesting problems. The problem of being a software company and often usually building a SaaS of some kind. And so variety of industries, a variety therefore of problems, but of course, lots of opportunity to learn from one another. And that's the intent of this meetup, to learn from one another, because there's so much to learn as if we've been doing this a while, and that's the intent. Okay, so this is one of the first times we've tried this new Teams format. So welcome feedback on this. Thus far we're doing some chat before we kick things off. Thus far we've been doing the Teams live meeting, where it's sort of a live stream where you've only been able to comment by chatting, less interactive, if you will. But it's been a year, and I think meeting etiquette. I think the early days of the inadvertent video camera and the accidental unmuting and the pocket dialing, and everyone's heard people running around holding their phone and all of that. We've all been there. We've all seen that. So I think people have learned. So I think feel more comfortable hosting our meeting now that we're more experienced virtual attendees, and this gives us all a chance to collaborate and chat with one another as well, which I think is definitely a key part of what we try to do in these meetups. Okay, enough about our group. Just a warm welcome to everyone. Please use the chat for any questions you might have. I'll keep an eye on that and nudge our speaker because while he's busy presenting and talking, and maybe I might just interrupt and with any good sounding ones, or on the off chance I happen to know the answer, I might just type the reply there as well. Please use the chat if you would like. Also, of course, as I mentioned, this is a Teams virtual meeting, so you're all able to use your video and your mics if you wish. In terms of etiquette, will be quite handy if you use the raise hand feature. There should be a little icon whereby you can raise your hand like so. I'm raising my hand like this, a little hand icon that appears over my screen right here, which is a nice way to attract the speaker's attention without having to like come off mic and butt in or anything like that. So that might be try using that if you'd like to join in with your voice, which you'd be welcome to either during the presentation or perhaps at the end. We'll sort of see how it goes. All right, more than enough speaking. Let me hand over to our speaker tonight, Sergio Mion, a cloud architect at Microsoft. Like myself, had the pleasure of working with Sergio for, was it 3 years now, Sergio?
Just about, yeah.
Yeah, three years. And so Sergio is extremely knowledgeable in all things Azure, so we're fortunate to have his expertise brought to us today. Sergio, do you want to introduce yourself, please, and your topic? I'll hand it over to you, sir.
Yep, I'm Sergio Mion. Like Adam said, I'm here in the Houston area. I'm a cloud solution architect focused primarily on application development and infrastructure, but also dip over into the data arena as well. If you would have met me a couple of years ago, I was working with many of you here locally, supporting our local customer base. Then took a year to go work with our worldwide team, where we try to basically serve as an escalation point for customers who are pushing Azure to its limits, using Azure perhaps in ways that we didn't dream up, and being very creative with how they apply the technology that we make. And then now I'm working primarily with our US education customers. And so this is a little bit of a homecoming for me back to this group. So, all right. So let's go ahead and jump in. I promise you there's only about 5 slides here, and everything else we're going to be inside the portal today. We're going to be on the whiteboard, just walking through and understanding what do we have available, what are the considerations when we want to take public cloud services and make them private. Okay, so let's just jump into that. and see where we go. So when we start this topic, when we start talking about the fact that you have been, or you will be, depending on where you are in your journey, consuming cloud services from a public provider like us, we typically, from a security standpoint, want to think about two different directions. Infiltration, that is what can come into our network, what can call our endpoints, from the outside in, and one that we don't talk as much about, but it's definitely something relevant and very relevant to the customer base I serve now, where we deal with topics like secure research and handling things like patient data or student or sensitive student data. Exfiltration is also equally important. And that's really the concept around what can leave our network. And so whereas we spend a lot of our time thinking about sort of bad actors on the outside trying to get in, certainly in a number of the applications that I work with now with our customers, we also have to take into consideration what happens when things go wrong on the inside, and what have we done to help with that. And so we'll keep coming back to that concept as we take a look at our topic tonight. So when we talk about private connection options, if you've been around this for a while, you've heard these terms service endpoints, and now we have private endpoints. And one of the reasons why you hear us talking so much about this now is not just that your expectations have been rising and rising around being able to secure, in particular, our platform as a service offerings, but also because for the private endpoint service, if you had dipped your toes in that about a year ago, there were a handful of services, and now private endpoint is supported on just about every major service that we offer. And so we're going to take a look at both. If it's been a minute since you've looked at service endpoints, it's going to be helpful to refresh our memory on that so that we can understand the differences in private endpoints. But just a couple of points that we see here on this slide. On the left-hand side, when we talk about service endpoints, and really when we talk about endpoints in either way, we're talking about starting in a private network, usually a virtual network, and looking towards or trying to access a PaaS service. Direction becomes super important in our conversation for the rest of the night. And so I'll keep toggling back and forth, which is why I kind of kept that in read mode. So if I have, for instance, a virtual network, and I have a set of services that are working within that, when we talk about working within our private network and looking out and trying to consume services, primarily PaaS services, that are outside of our private network, those two enabling technologies are service endpoints and private endpoints. Two different ways, very similar in many regards, with some key differences. Okay, so direction is important. Now, one of the things we're also going to come across a little bit later, so we'll just put a pin in it, is sometimes it's also important to think about what happens when the PaaS service has to talk back to other services that might be living here. And that we'll come across it in one of the demos that I put together. We're going to see this, and in fact, we're going to see where we've had to change the design because of some of the realities of how this is happening. But this is where we are starting. So what are some of those differences? What are some of the characteristics? Well, normally, if we have a resource sitting inside of a virtual network and we're accessing one of our platform as a service offerings, we're doing so via a public endpoint. So we're doing so essentially over the internet, public endpoint, and that's the way that we've always done it before service endpoints and private endpoints came into being, or became as pervasive and as available across so many services as they were. And so in the case of service endpoints, and we'll see some concrete examples of this with one of our services, one of the compromises in service endpoints is that the endpoint that we're going to is still a public IP, okay? The difference is that the traffic now from your virtual network to that platform as a service offering is going to stay on the Microsoft backbone. It's going to stay there versus routing around or appearing to be external. And the second piece to that is one of the challenges that we've had historically when you're trying to secure or trying to firewall off your platform as a service functions that you're using is that because you're given total flexibility in your virtual network to set up addressing any way that you want, if we were simply to have all of that arriving at the doorstep of one of our PaaS services and said, hey, let's block everything that's not from 10.0.0.10/24. Well, there's a lot of people that have that. And so when you've looked at our IP access or our IP address restrictions, and we'll play around with those, you would have seen that we limit that to public IPs. Because on the internal IPs, be it the 10 networks, the 192 networks, the 172s, there's so much potential for overlap that we don't have any way of distinguishing one virtual network and their address space from another. Service endpoints, however, solve that problem. And when we enable service endpoints, and we will in just a minute, you're going to see that now we're giving that PaaS service the ability to distinguish our virtual network traffic from everybody else's. And so we're able then to firewall off at that point. And so that's essentially what service endpoints are all about. Service endpoints are enabled in the virtual network itself. And we'll play around. It'll be easier to see it, so I won't say too much more on that. But essentially, the traffic is staying on the Microsoft network. And on top of that, by assigning service endpoints, we're giving the PaaS services the ability to tell the difference between different people's private networks. Okay. Private endpoint goes a little bit of a step further. So in a private endpoint, again, we're still trying to provide secure access from our private network out to a public PaaS service. And in the case of private endpoint, we actually end up landing a virtual network interface card for that PaaS service in our virtual network. So it has an address just like anything else. And we'll see some of the things that Azure DNS does to sort of obfuscate or I guess abstract away the complexity of how DNS works and how we translate, from those domain names that we've been using for storage accounts, or function calls or app service sites that we're running now. We'll see how Azure DNS helps us so that we don't really have to think about it from an application development standpoint, but we actually get that IP address we get a virtual NIC landing inside of our virtual network. And one of the things that allows that service endpoints did not is that allows us to consume some of these public PaaS services even over things like ExpressRoute or VPN tunnels. However it is you've connected from Azure to on-premises, if you have that private connection, now you're able to take advantage of the same sort of private connectivity that service endpoints have provided to us for years, but now take advantage of those using private endpoints in a way that you couldn't with service endpoints. And so that's really great, because from the perspective of other resources living inside of your virtual network, or from the perspective of other networks that might be peered to that virtual network, it just looks like another endpoint sitting inside of that network. So Azure Storage, may still have a domain name, that's XYZ, but at the end of the day, it has a leg in your network, and that's how you're able to access it. And again, we'll look at that in just a moment. But because of some of those differences, we still, with private endpoints, keep the traffic on the Microsoft backbone. And in addition to that, one of the things that we'll see is that we're going to have some advantages in terms of simplifying our exfiltration story. That is, when I'm sitting inside of a network, what kind of complexity is there in preventing conversations from resources that are in our network speaking out to public PaaS services? You're going to see that private endpoints help simplify some of that. So That's essentially where we're going on that. But it is really, if you've read that 100 times and you're still a little hazy on it, or if you don't spend every day on the infrastructure of the service side of the house, maybe you're primarily leveraging platform as a service, let's actually flip over and start to look at this in the portal itself, because it makes more sense when you actually start to work with it. And so just as a little sort of tour of what we're going to look at, we are going to start out in this Explore resource group. And is the text large enough here for everybody to see? I can try to make it a little bigger, but we okay with
Yeah,
that?
I think that looks good, Sergio. Yeah,
Okay,
go for it, man.
great. All right. So within the resource group, we're going to kind of explore the idea of service endpoints versus private endpoints before we try to use them. We have a few things that are listed in here. I have, and I am going to shrink this up a little bit so we can see this. Here we go. I have a couple of storage accounts. So Explore 7776666 is set up with service endpoints, and Explore 999 is set up with private endpoints. What I've also done is I've also created a virtual network where we have two different subnets. One where we're leveraging service endpoints and one where we're leveraging private endpoints. And so within that, you'll see that we have a private, which is going to be for our private endpoints. We have a public, which is going to be for our service endpoints. And then I have just a couple of virtual machines that we'll be using to kind of bounce between, one for the private side and one for the public side, and we'll start to explore. So let's take this one topic at a time, and let's take a look at Explore 7776666 and see how this is configured. Now, this is a storage account. This is one of our fundamental services. It's been there forever, continues to evolve. This list on the left continues to get bigger and bigger and bigger. So let's spend a little bit of time inside just a couple of these. In this storage account, all that I've done is I've created a blob storage container, and I called it Explore. And inside of that blob storage container, I just have a single image, okay? And so if I take this image now, so if I go and look at the properties here of this image, I am going to, you can come down here and copy the source. I'll just pop open another tab. And basically inside of here, we are going to see, if I do that correctly and not copy half of it, I apologize. Copied the wrong one. All right, there we go. This was an image I made up for a different session, but I've liked it, so I've kept it. So outcome of that session was similar to the movie if you've seen it. So that went well. So here basically I'm sitting on my computer right now, which is an arbitrary computer on the public internet. Now I have disabled any kind of access keys or any kind of shared access signatures, just because it's not relevant to what we're going to look at right now. The only difference would be I would add some more to the URL if we were using those. But right here, up at the top, we have the customary DNS entry. So as you've always done, you specify your portion of the name, and then that gets added to the .blob.core.windows.net, which is the blob storage portion of the URL. Okay, so that's where we're starting simple. And so from a network perspective, why was I able to do what I was just able to do? Let's take a look at that. From a network perspective, as far as the firewall that's built into almost every one of our major services now, our public PaaS services, I am allowing access from all networks. So unsurprisingly, I'm sitting on the internet and away we go. I do not have any private endpoints configured in this one. And so that's what we have. Now, I mentioned the fact that service endpoints, that is your ability to manipulate how, in this case, a VM, in our situation, so in our particular setup we have here, I'm showing you what we've called the public, and I'll switch colors here. There's a public subnet inside of this virtual network. And inside of there, I have a VM. Okay. I want to have an opinion about how this VM is going to reach the storage account that is sitting out here as a PaaS service in its own infrastructure, in its own separate network. So that's what I want to do. Now, the first mechanism I'm going to use to do that is I'm going to configure a service endpoint. Okay. Service endpoints are not configured in the service itself, that is storage, but in fact, it's a configuration on the virtual network portion, this red box here. And that's because we're changing the way that routing is working behind the scenes. Okay, so let's take a quick jump back. Let's go over to the virtual network where that's virtual machines, where our virtual machine is living. And so I just called it explore.vnet-vnet. Now this is where my virtual machine is sitting that we'll be using in a moment. And if I scroll down into the settings area, I can come down to service endpoints. And right now, I don't have any service endpoints configured at all. And so let's start by looking at the public VM. Okay, and let me resize this so this isn't completely ridiculous for you scale-wise. All right. And let me just resize this window because it's, of course, demos. It's doing an amazing job of scaling on me. But it's even getting smaller. That's wonderful. All right. I'm going to... I'm just going to bump this up for the moment, and then I'll fix it. Oh, there we go. All right. Let's take a quick look at what this translates into. So if I come over here, I'm going to get rid of all of the URL pieces. I'm sitting on a virtual machine in that virtual network that we just looked at. So when I do that, you're going to see that this gets translated into this name, and this name refers to a public IP. Okay, so that public IP is something we'll come back to in just a moment. So right now, if I look at this, I could say, well, this makes a lot of sense. I haven't had an opinion, so I'm accessing this public service from its public endpoint over the internet. Now, here's one of the challenges. I talked about the fact that one of the things we do with service endpoints is we influence the routing. Remember, we talked about the fact that when service endpoints are in place, when I communicate from my VM to that storage account, that's going to happen on the backplane. But how do I prove that? How do I know that, right? You can't see it. It's happening behind the scenes. And that's where I want to make sure that we take just a moment to explore maybe a tool you don't use as often. So back in your Azure portal, one of the ways that you can get insight into what's happening behind the scenes in our network is Network Watcher. Now, you may have used this to verify connections between two VMs, but today I want to look at one feature of the Next Hop tool that's down here in the Network Diagnostic Tools. So let's take a look at what happens. So I'm going to go ahead and select my Explore resource group, my public VM. That's the NIC of my VM. That's fine. There's only one. That's the IP address, the internal IP address of that VM that we're sitting on. And I want to say, oops, I copied the wrong one. I want to take that IP address that we resolved because this tool only uses IP addresses. Okay. So this is what that storage account looks like to the VM. So let me ask Azure, well, what's going to happen next? So I'm starting here and I'm going to this IP address. This takes a couple seconds, usually 10, 15 seconds. And let's see what happens when this returns. And I'll increase the size of this again. As usual, it's 5 seconds when I run it for myself and 15 for anybody else. This is what we're going to pay attention to right here. The next hop type is going to be a hop out to the internet. This is a public endpoint. We have not done anything to this storage account, so nothing is surprising about this. But let's now go quickly back to that storage account. I'm sorry, back to the virtual network, and let's set up that service endpoint and see how it changes things. Okay, so, and I opened a couple of these so I don't have to keep navigating away. Let's go back to our virtual network where we were. Sorry, this is so gigantic. All right, let's go back in there, and we saw there was an entry that was empty for service endpoints. Let's just create one. So when we create a service endpoint, these are the services that support service endpoints. These are the services that we can influence routing from a private network to them. And in this case, Microsoft Storage is what we want to do. The subnet, now you choose this down to the subnet level. That's how it's scoped. And so in my case, for the virtual network I'm sitting in, I want to do that for the public subnet. That's the one, it's an arbitrary name, I just made it up, but that's the one where the VM is living now. So let's do that. That normally takes 10, 15 seconds again for this, doesn't take too long. And once we do that, we'll go back to the VM as soon as this is done adding, and we'll look at the address again, see what's different, and then keep going from there. Some of these things, for some parts of the demo, what I'll tell you is that I have some of these things pre-configured as we keep moving along. But for some of these first steps, I did want to try to add the reasonable delayed steps, just like this one right here, so that you could actually see it. If you've never had a chance to do it, or you didn't want to mess up your setup, let me mess up mine, and we'll learn together. All right, so let's go back to that public VM, and let's just do a domain name translation. And we're going to see absolutely nothing has changed. Because remember, with service endpoints, we're still working with a public IP. However, I told you that it influences the way that routing is going to happen. So let's go back to our network watcher. It's the same IP address. So now when I go from the VM to the storage account, let's hit next hop again. Wait our 10, 15 seconds, and let's see if there's any difference. And again, Network Watcher, and specifically this next hop tool, is allowing us to, hasn't yet taken effect. Let's see. I'm going to do it again. Is allowing us to get insight into the routing that happens even away from our network that we're configuring. We talk about it all the time with platform as a service, that from the perspective of what we get and what we give, with a platform as a service offering, what we get is reduced management and whatnot, but what we end up giving is some visibility. So let me jump back here. I have configured, let me make sure I'm on the right one, for the public. I did that, Microsoft Storage. A little bit of this demo I know is going to be me waiting for something to take effect, but let's just, it usually goes fairly quickly. So let me just make sure all is well, because it's not yet hopped over. It's still telling us that the next route for this is going to go in that direction. So let me copy this, because I have a feeling I got to reload this page. But we shall see. Yeah, let me reload this page. Because what we should find now is that the routing from the VNet to the service is going to be different. And we should be able to verify that in this tool. Okay? So I'm reloading this page. I'll go back and select everything. Yes.
So give us a spoiler. What is it supposed to say, Sergio, instead of internet?
Well, you're going to have to wait. No. It is going to imply that it is going to be routing via service endpoint and not internet. So let's see here. Let me go public VM. Grab that one. That one looks good. I know.
Drum roll.
I know. Demo gods, right? I mean, 9 times out of 10 it works when you're prepping. And
oh yeah, always. Mm-hmm.
Always. There we go.
There it is.
So this is the price of doing it live. Now I'm still accessing a public IP, but I'm never leaving the Azure backbone. And I have proof of that based on this diagnostic tool. Now it's virtual network service endpoint. And that's going to become really interesting because a couple of things just happened there. Yes, I'm now routing traffic, within Azure, even though it's a public IP. And on top of that, one of the things that now becomes possible is that if I go back to the storage account, okay? So let's go back to the storage account now. I'm going to see one of the options is now lit up that wasn't before. So if I come back to networking, I've been happily sitting with access from all networks, but if I wanted to start to ratchet this down, then I could say selected networks. I only want this to be, this storage account to be accessible from selected networks. And now if I came in here and said, hey, my IP address was like 10.0.1.4, right? So I'm going to start typing it in. Here we go. I want to restrict it to just my VM. Can't do it. Because like I mentioned before, the storage accounts or other public PaaS services like this don't know how to differentiate private IP spaces from each other. Two different customers can choose the same ones. I can't guarantee that. However, by doing what we just did with service endpoints, if I come up to virtual networks now, I can come in and say my Explore VNet, that's the one we've been working with. And now if I look at subnets, one of these things is not like the other. So up here, if I said my Azure Bastion subnet is what I want to do, it's going to say, no, you can't do that. You need a service endpoint. Or I want to say, oh, my private subnet where I have my other VM, I want that one to be okay. I want to be able to access a storage account from there. Well, no, you can't do that. And so the only one that I enabled the service endpoint onto is I bridged that public PaaS to VNet connection into the public subnet. Now I could have done multiple, but for the purpose of compare and contrast, I only did one. So in this case now, I'm going to come back again just to verify. This is me on, the internet, happily, accessing this, no problem. Okay. And now if I come back over here and say, I only want this VNet to be able to reach out to this thing. I'm going to say that. Great. I'm going to hit add. Here again, I'm going to pay a little bit of a penalty here when I hit the save button because it's going to take a moment to do it, but I want you to see it. Not too bad for this. So now if I come back over to the public VM, this is the VM that is sitting in that subnet that has that relationship established. What I should be able to do is let me come and copy this. Now I'm going to cheat a little bit just to show you more tools because more tools are more fun. Instead of doing this in the web browser, let's just assume I only have a terminal. And let's just do, if we're in PowerShell, like an invoke web request. And in this case, I'm just going to put the address that I'm trying to pull. And what I care about here is this status 200, and I can see that this actually came back, which is great. Now, that's from here. Now, let me go back to my desktop and reload. And now, as expected, I can no longer access this from the internet. However, let me go to another VM that is in the same exact VNet as the other, just in a different subnet. Now, this is the VM that's sitting in the private subnet. And I'm going to stop fighting the scaling for the sake of time and just bump this up to ridiculous levels of font. All right. So let's come over here. Now I'm sitting in another VM, still in the same virtual network, but a different subnet that is not associated with that storage account. And let's do an invoke web request from over here. And here we go. I can't get to it either. I'm in the same virtual network and I can't do it, but I'm in the wrong subnet. So this is the correct subnet all day long. I'm pulling back the file. This is a VM in Azure in the same virtual network, but a different subnet. Can't do it. And then back in this world, of course, if I, on the public internet, can't do it. Service endpoints allowed us to go from a situation where anybody in the world could access that to just one particular VNet in Azure, which is fantastic. And so when we talk about, if we bring this whiteboard back up, and this poor thing, I'm going to go in so many directions. So if we talk about Azure storage, okay, as a platform as a service offering, and we're concerned about requests to it, we just improved our infiltration story a lot. We blocked internet, we blocked other subnets in the same VNet, and if we showed you other VNets, other VNets would be blocked. So we only have that one path from that public, what we called, there's nothing special about that name, what we called the public subnet is the only one now that is allowed to access that service. Okay, which is great. That's that's awesome. However, what if I had concerns about somebody sitting on the public VM and writing data out to another storage account? Maybe they're stealing data and they're just arbitrarily writing that out to an S3 bucket, blob storage, you name it, like any other public endpoint. What can we do about controlling the direction of in the VNet to out to the outside world? Well, that's something that we can control by controlling the perimeter of the virtual network. And we control the perimeter of the virtual network by using network security groups as one layer. It's one way to do that. Okay, so let's go back in then and see for the public subnet. Okay, so let's go back to our VNet. Let's go back into this subnet where our VM is living. It's the only thing that can reach out and talk to the storage account now, but we have another issue that's sort of looming. So let's look at this public, this subnet here. Great. It looks like we have a network security group called Explore Public Subnet NSG. So let's go take a quick look at that and see what rules are in place. Perfect. Here we go. All right. So here we are in a set of rules that are applied to that subnet where that VM lives. If you've been here before, this should be familiar. What you're going to see is I only have the default rules specified. In terms of what can come into the subnet, anything from another VNet can come in. Anything VNet type traffic can come in by default. That's a default rule you can't delete, but you can put a rule that has a higher priority that can override that behavior. Any Azure load balancer can route traffic into your subnet. And after that, everything else is denied. But we're not super concerned about the inbound. We're concerned about the outbound. Because right now, as you well know, if you've configured these before, the default rules say that I can go anywhere to VNets. That's allowed by default. And the second one is a particular concern. I can go anywhere out to the internet that I want. Okay? So if I came in here and I said, so let's go back to this public VM really quick. So if I came out here and did just a slightly different request, what are you guys not going to give me a hard time about? Kroger.com. Yeah, we're regional enough here for this. Okay, one of our regional grocery stores. If I got that address correct. I love that I chose the one that I got incorrect. I should have done HEB, right? That should have been the one. I'm not going to fight this.
The audience is suggesting HEB. There you
go. I know. All right, there we go.
There it is for the win.
Coming down, right? Yes, I know. I know you're really upset with me because I'm not doing this through the browser. But here we go. That's HEB, right? And that's because this virtual machine, I knew I was going to get in trouble for the Kroger thing, but that's why this virtual machine can reach out to the internet is because by default, that rule is configured the way it is. So now that we had a lot of good opinions about what can come in, and we've even had a nice little path out to a storage account, let's just go ahead and arbitrarily say, any source, destination service tag, anywhere to the internet on any port is blocked. Okay, so rather than doing a giant allow, let's do a giant deny. Let's make this a lower number than this other default rules because the lower numbers get evaluated first. It gets evaluated in order, and the first rule that's true wins. So let's make this a low priority, which is actually a higher priority. And then let's just say deny internet. Okay, perfect. Away we go. I think I did that right. Yeah, deny internet. We overrode basically the default rule that said internet was allowed. So let's go back to our public VM. Let's try our infamous HEB again and see what we can see. I know what this is already. I've already been down this path. Let me get out of PowerShell, come back into it, since it's happily holding on to its previous connections. Okay. And we're giving that a chance to, actually, I didn't even check if it applied yet. That's also my bad. Let's see, are we good? All right, deny internet. Let's make sure I did it right. I did it on the right one. Explore public. I'm sitting on the public. We're back to a waiting game. I think it'll be pretty obvious where this is going, because at some point here, we're going to block our ability to get out to the internet as soon as that rule trickles its way on through.
Question from the chat while you're waiting for that to happen.
I don't know. Oh, user firewall equivalent. I haven't configured that before, but I guess are you trying to equate network security groups to that, or the firewalling at the service level, at the storage account that we just did?
And McKenna, if you want to come off mic, go ahead.
Yeah, I'm just looking at equivalents because of the Kubernetes equivalents as well as the UFW on a Ubuntu box.
Okay.
So I'm assuming this is the equivalent of that. That's just the comment.
I just haven't configured it, but I'm imagining based on your comments that it is.
Yeah.
What this, basically the rules that we're applying that I just applied can be applied either to an entire subnet or down to the NIC level. And for the purpose of this, I've kept it at the subnet level. We can now see that, HEB is really unhappy, and as soon as this times out, because I've now prevented any outbound to internet, here we are. Again, there we go. Unable to connect a remote server once the rule finally propagated. This VM no longer has internet access. However, what then of this image? Well, wait a minute. You said that this was set up to traverse the Microsoft backbone, and you're right. But remember, for service endpoints, one of the things that we saw when we talked about them at the very beginning was the fact that we're still interacting with a public IP. So from a network security group level, specifically when we talk about that service tag that says internet, it's saying, wait a minute, this is an internet address. That's a no-go. One of the things you have to give up, one of the things you give back when you're leveraging service endpoints is we have effectively done what we wanted to do, but we're going to have to open up the outbound a little bit more to be able to get out to just these IPs that have to do with storage endpoints. So let's go back to that NSG where we were. Let's add another rule. Okay. So let's go back over here, and we're going to add another service tag. A service tag is a convenient way for you to not have to know every possible IP address that a particular service might use. And so in the case of internet, we did that. But I'm going to come down and say, you know what, internet bad, but Azure storage, yeah, I'm actually okay with that. And either I can say, I'm okay with any IP address for any storage in any region in the world, or I can get a little more granular than that and say, I'm good to a region. Now, in this case, I'm in central US. And so I'm going to allow it. I'm going to allow, and I could just do 443, but I'm going to allow conversations to our storage public IPs. I'm going to allow that. Okay. So here we go. Allow storage. I'm going to have to bump that down because the first rule wins, right? So if it sees that deny internet and it's like, yeah, it is internet, then I'm done. So I got to get this underneath. So let me do this. So I'll say 101 and add it. And then I'm actually going to have to go into this one and change the priority to like 102. I know I should be leaving space. I hear it. I can hear it in the background. But this is the last change we're going to make in this one before we move on. Okay. Well, Adam, I saw that comment. I might agree with that from the perspective of a NSG or a network security group that's applied to a virtual machine's NIC or network interface card. But at a sub level, it's actually totally separate from any of the workloads that happen to be in that subnet. It's just it's a giant gate. Like what I'm configuring now is a gatekeeper to information flowing in and out of the subnet before it ever even gets to a particular VM. But with that little tweak, I agree with you. Okay. All right. So we're going to allow that. We're going to say that. We're letting that trickle through. We'll come back over here. Again, we're just trying to access, and boom, here we go. Because we allowed basically the conversation out to storage, we're fine. But we're still blocking internet because that's not one of the IP addresses that has to do with storage. Now, you might say, like, this is good. Like, we're good to go. So why would we ever want anything other than service endpoints? Well, there's one more exfiltration concern that is still kind of wide open here. And that is, if I'm sitting on this virtual machine, I cannot go to the internet. That's fine. Good. However, I do have a service endpoint in place that is going to keep my traffic, going to storage. In this case, I'm just going to say S. I've got this happening, but the problem is if you don't read the little fine print carefully when you're setting it up, I establish a service endpoint for an entire service to a particular subnet. And what that means is because I allowed storage type traffic to go out, which I had to, didn't have a choice because it's still a public IP. I now, from a VM perspective, could get to any storage account where I had access in all of central US because I chose that service tag that said storage central US. And for some situations from a compliance standpoint, we're not really happy about that. Right? You'd rather be able to lock it down and say this VM can only talk to this storage account. And I'm not talking about going and setting permissions here. I'm talking about preventing a situation where I set up another storage account myself as a bad actor in central US, and then I'm exfiltrating data out to this because from a network perspective, you haven't prevented it. And in fact, with service endpoints, you couldn't prevent that. Because if I wanted the benefits of this, which are amazing, I have to do it at a per service level. So it's all the storage. Any traffic going to storage is going to do this. And from an NSG perspective, I wasn't able to, I had to say, I'm using a service tag for this. And you say, well, is it fixable? Well, yes, it is, but not without introducing additional pieces. Maybe I'm going to run all of my outbound traffic through a firewall, and I'm going to have rules there. Maybe I'm going to have rules set up in a NAT service so that outbound conversations have rules around them, et cetera, right? So these are other ways around it. So we're still getting a number of benefits, but one of the pieces of feedback we continued to hear about service endpoints was one, regarding exfiltration, was this scenario. So just be aware that that's sort of where we're at. So a win, we have secured things, but it came at a little bit of a cost. Okay. All right. Let's quickly go back now into the world of the other storage account. And let's just quickly contrast that to private endpoints. So here again, and I'm going to accelerate the pieces that we've been through already. Just keeping an eye on time here. Okay. All right. So now in this world, again, same kind of setup. In fact, the exact same setup. I have an Explorer container. It has my my little image in there that we've been using. Life is the same in that regard. Let's look at the networking. From a network perspective, I'm currently allowing all networks. This one, however, I wanted to configure with a private endpoint. Now, I knew that we would be at this point time-wise as we waited for the other steps. So I already established a private endpoint. I will show you what the menu looks like though, but we already have one established. When I want to set up a private endpoint, it's pretty straightforward. I give it a name. I go through, I tell it what region, and in this case, all of my stuff is in central US. There, oh, not north central. Always when I'm looking for, there it is. Of course, it's always the one right above it. So I just give this thing a name. I won't actually create this, but I do want to show you the next menu here. So in here now, I have to set up a private endpoint for a specific aspect of this storage account. And in this case, it would have been blob. And why is that? Well, if you remember the URL that we looked at, this part of the URL changes. It's blob right now. If it were table, it'd be table, and so on. And so you have to distinguish a little bit more because DNS is involved in this. So when the DNS server that handles this portion of the name kicks in to be a part of this conversation, that's why we have to get so specific. And it's a little bit different for every service, but for a storage account, that's what we're choosing. You can absolutely set up more than one, right? So it's blob, table, queue, static web app if you're using that inside of a storage account, that's what web is, etc. And then away we go, and then we say configuration, and there's a little bit of domain or DNS magic or domain name service magic that goes on here. So again, we tell it what subnet do you want me to actually put a little virtual NIC card in, because that's what private endpoint's going to do, and I tell it, and I've already done all this. So the result of all that is if I go back to my virtual network, now that we configured that, we know that in this main interface, I can come through and see everything that's been issued in IP address. And if I look right here, this is my private endpoint. It looks just like any other NIC sitting in that in this VNet. And so the storage account, that Explorer 999, has a private IP address in my environment because I set up a private endpoint. Let's quickly put that to the test. And let's see some of the differences based on what we just saw. Let's go back to that Explorer, the one that has a private endpoint, not a service endpoint. Let's go and do the same thing. Let me go grab a URL really quickly. It's going to come in here. Yep. We'll do the same thing. Let me just go grab the URL off of this guy. Let's come into the private VM. I'm going to strip off some of this because we're going to just take a quick look at what's happening from a DNS perspective. And I'm just going to do a quick little DNS lookup. And now we have some different things coming back. Now I'm internal, I'm in the VNet, and the DNS now responded with a different canonical name or a different CNAME record to private link. Private link was also automatically added, and you could use your own, but by default, it leverages Azure's private DNS service. So if we come back over here to private DNS zones, we see that it automatically created one for that blobs service there. And in there, it's going to have, and I'm sorry, I should have just stayed there. In here, it has a record for an A record pointing to our IP address, the one it got issued for Explorer 9999988. And so when you now resolve the same endpoint that we always did, Azure's DNS is kicking in and doing the magic for you. And what do I mean by magic? Well, the magic is this. If I fire up a terminal on my own system out on the internet, okay, and I come through and I say, well, let me look it up. I want to know what it is. I'm going to look up the same thing. Now I'm on the internet on my own system. Try to make that a little bigger there for you. Well, now wait a minute. I'm getting two back. And now I'm getting issued back an A record for the public endpoint. That's because there's intelligence in the DNS server. Essentially, it's a split horizon, split brain, whatever you like to refer to it as, where when I get to the portion of resolving, the blob.core.windows.net portion of my name, it knows if I'm on the outside, give me the public IP. If I'm on the inside, give me the private IP. One of the things to note is you might get a little concerned and say, well, wait a minute, I thought you said private, and it is private, but the DNS entry and the DNS servers are still resolving. They're just intelligently resolving based on where you're at. Now, this public IP address, just like we did with service endpoints, is not going to do me any good at all as soon as I firewall off anything internet-based. And we do that in a very similar way. So if I come back over here to that storage account, same exercise. I don't want public internet access. I don't want that. So if I went here and I replace this with, there we go, I'm seeing the data again because I'm going to the one that's open from the internet. Come down here, go to networking. And let's see, well, that makes sense. It's set for all networks. So, okay, I see what, I can understand that. Now, I'm going to show you something that is interesting. The minute that you switch over to selected networks, it then becomes a deny all, and everything else below this in this screen is an exception to the deny all. Okay? Now, if I try to add an existing virtual network like we did before, because I want to allow that traffic to come from that virtual network, I could come through and try to set that up, but I'm going to be in the same spot that I was before, where it's like, well, yeah, but I want to do it for private, but I can't because there's no service endpoint. I haven't, as far as this top is concerned, I haven't given Azure the ability to know that my subnet private is uniquely identified in a way that it can firewall off. So what can you do? Well, you can go and create a service endpoint. That's fine. Or what you can do is realize that if we just say selected networks and we say nothing else, then nothing external to storage can access storage. You say, well, how's that going to help me? Well, storage put an internal leg inside of your network. It considers that traffic to be internal to itself. That is a very different situation from service endpoints, because in this case, I have a single leg extended from my service account over, or from my storage account into my network, and that's what I have. And so if I come through and save this just as is, I didn't specify any virtual networks. That's a service endpoint concept. I didn't give any exceptions here at all. So selected networks is deny everything unless it happens to be internal to my storage account, which it believes that it is. So if I come back here and we go ahead and try to access this, and again, we might be playing the game of timing, but bear with, I can access it. But that's because I'm accessing it from a leg that it has put into my VNet that it considers to be internal to itself. If I go back over to the public section, and I'll clear some of this out, and I say, go ahead and go here, 9 to the 9s, the new one we're doing. As soon as this thing kicks in, oh, yeah, no, this is it. This is it. This is the behavior. I'm sorry, I'm thinking public. This is the behavior because I'm not sitting in my terminal, because this is just another thing with an endpoint inside of my network. Okay? I'm not having to do it subnet to subnet. It's just another IP address in my network. And so if I come out here, first of all, let me just get rid of this and do it faster. This way. Let's see what our story from the internet is. There we go. From the internet, I'm blocked. But from within that virtual network where I live, because it's just a private IP address, it's an internal call. Storage considers it internal. And so the deny all external networks doesn't apply to this. So now we've set up a situation where, different to what we talked about from an exfiltration standpoint, I now have my virtual network. I'll abbreviate the way that we normally do. This has an actual NIC inside of this with a 10 dot address, if this is storage. and I have a one-to-one relationship now between my VNet and that storage account. I can't see any other storage accounts. I don't have any service endpoints. There are no service endpoints established with my virtual network in this scenario. And if I go through now and I say, well, let's prove that out, right? So let me go into the network security group for the private subnet, and let me just block all internet. Okay, so let me come in here for outbound rules. I want to do the same thing. I'm going to say, I don't care where we're starting from, but if it's ending up on the internet, then that's a no-go. That's fine. We'll just make this really quickly. So now I'm going to be locking down internet on this private VM. Now, last time we did this, we found ourselves in an oopsie situation because the storage endpoints were still considered to be internet addresses. And the difference you're going to see at this point, and we may not wait for it to go all the way through, is that's no longer true. It's a local address. It's a 10 dot address now. So I don't need to go and allow access to all storage from an exfiltration, from an outbound standpoint. I can just say deny internet, period, end of story, and I'm done. So now this other subnet that we've been working in, where this private VM is sitting, now has no internet access at all, still can get to one and only one storage account in this case, and did not need a service endpoint to open up access to all storage account IP addresses to make that magic happen. And that's one of the reasons that from an exfiltration standpoint, private endpoint is getting so much attention. Now, the other benefit of this is because it's just another IP address in your VNet, if this were peered back to a VNet that, back to a hub, for instance, or to a VNet that had either a VPN connection or an express route connection back on premises, you would benefit from the same thing. You could access the storage account in a one-to-one fashion, just like we did now from on premises, in the exact same manner. You could do that now. You don't have to play goofy, go on the outside or, navigating out in that way. You could do that internally as well. And that's true for every service that basically we support right now with private endpoint, which at this point is almost every one of them. Okay. I tried to use a very familiar service in storage accounts, and we did this deep dive. And I know we have, what do we have, about 20 minutes left or so, Adam, or roundabout?
Yeah, something like that. But I mean, we'll also go with the vote with the feet guidance. So if there's still people here and they're still interested, and no one's dying from hunger.
Absolutely.
But
no. So the reason why I wanted to start here was, if you looked at the description of this talk, we wanted to take a reference architecture that was just based on PaaS services and then start to say, okay, well, now with everything that we know about service endpoints and private endpoints, how can we apply that to an architecture? And one of the things that we're going to see pretty quickly is, well, we've got a few more things to think about. Okay. So really quickly, while I bring this up, and happy to have any questions while I kind of bring up what the context is for this next section.
Yeah, there are some questions, which are a couple of generic ones that folks have regarding, I think, the lack of service tags is a problem.
It continues to increase, but certainly we feel that pain. You called out MS Graph. I'll tell you probably the biggest one outside of that that comes up is Azure DevOps is another one. That's a really big one that comes up quite a bit. So, I mean, the feedback received, they do continue to add them. Yeah, and when they're not there, if you've been through that, yeah, it's painful, because now you are dealing with those lists of IP addresses and domain names and everything else that you're having to feed in.
Mm-hmm. Also, the engineering teams are adding private link support for services more and more. So, for example, Azure Front Door, the new premium SKU of that, for example, now allows via private link from Front Door to your service backend, allows you to then make your backend private, like your storage account, like your web app, and Azure Front Door makes that private link back there to it. So
Absolutely.
seeing those changes happen to ease that pain. Hopefully that answers the question. Thanks, Sergio.
Yes, and I do see that as well. The note about automatically pulling down, basically via RSS, if it's the way that I think you're referring to, that list of IP addresses. But yeah, they get updated over time.
Yeah, all the time. Yeah, that is painful.
Mm-hmm. It is. If you're in that game, it's a painful game. That's for sure.
Private link and service tags are, I think, the way forward. Power BI is a big one. Yeah, that doesn't support yet private link. It supports private link to Power BI, but not from Power BI to the backend services that I'm aware of. So that one.
Well, and that's one of the interesting. It's a very interesting point, and something that we're going to kind of hit on in just a moment here.
Okay,
maybe
great.
Power BI, but these kinds of a kind of way of thinking. Because one of the things I did to you, which was probably detrimental, and I apologize, but it was the only way to look at it, is I immediately started talking about, oh, private link, service endpoint, let's throw a VM, because it's got to be a VM that's accessing these things, right? And that's not true. And in the example that we'll look at, we're going to talk about a couple more things we have to think about when we have PaaS services that all have their feet and their toes inside of a virtual network where maybe a VM doesn't live at all. And it's just a virtual network. It's just a private network where we're commingling PaaS services. And we don't often think in those terms, but that is another possibility of the two things that we looked at tonight, service endpoints and private endpoints. So let's quickly look at the context, and then we'll get through this. If you've been with us for any amount of time in any of our demos, I mean, this use case, somewhat incredibly so, has become almost trivial, which is impressive because I used to have to worry about things like image metadata and buying products that could do that. But in this case, we have our age-old use case of I'm going to throw images into a storage account, and I need to analyze those images and generate a set of keywords based on the content of those images that I can then save into a database as metadata. And so basically, I need to generate some image metadata, and I want to do all of this, if possible, with as many platform as a service offerings as I can versus infrastructure as a service offerings. So just a couple details. The metadata should include keywords describing objects found. Not a problem. If you've been around cognitive services and specifically computer vision, you know that we can do that. Metadata results should be stored to a database. And I killed the last portion of this, which we probably wouldn't have time for anyway. But yeah, we're going to write it to a database and not do the third. Constraints, use PaaS whenever possible. One that I put on myself, which I'm somewhat glad I did because it led to other discoveries, is use no code, low code whenever possible. Like, let's just go all out. If we're going to do this, let's just do this. All solution component endpoints, whatever I choose to use, must only be accessible from within the virtual network, period. And I'm choosing all PaaS services. So that's a constraint. No incoming requests from the internet are allowed into the virtual network, another constraint. No outgoing requests to the internet are allowed from the virtual network. So again, infiltration, exfiltration requirements on this one. Okay, that's the basic challenge. Not a lot to that. And what I was thinking in terms of how we would look at this, I took one of our reference architectures and then kind of turned it on its head a little bit and paid the price. For my compute, that is where I'm going to basically orchestrate everything. Azure Functions would have been great, and it would have avoided some of the issues that I hit, but I'm in some ways glad that I didn't choose it because it's going to be a great conversation to have. I chose instead Logic Apps, but not just Logic Apps, but our new preview version of Logic Apps. And as we say until we're blue in the face, when something is in preview, it isn't perfect. It's still evolving. We try to be brutally clear about that. We really don't like to see it used on production workloads. Of course, we can't prevent you from doing that, but As we'll see tonight, there's some weirdness in the preview that I'm actually taking back to the engineering team. But we're going to use it. We're going to do it. And we're going to see what happens. Now, the Logic Apps preview, if you haven't kept up with that side of the story, the 30-second story there is that there's always been an engine behind all of those pretty graphics and all that drag and drop that we do in Logic Apps. And what we did is we rewrote that engine to basically be an extension of Azure Functions. And that's great that we did that, because when we built the foundation of Logic Apps engine on Functions, we automatically inherited all of the innovation that's been happening in Functions over the last few years. One of those innovations is that we're going to use today is the fact that we can host Azure Functions on app service plans. So we get a lot of all the functionality that we've been getting through that VNet integration, all these things that we'll talk about. We get that for free just because Logic Apps now take those workflows that you still design the same way, but the engine just happens to run it through Functions rather than, or through an engine built on Functions rather than the proprietary engine it was before. Okay, in preview, still coming out. All kinds of other benefits we could talk about later, but that's what I chose, and that's what I chose. So there were some things. For the database, because what we're getting back from Cognitive Services are JSON documents, no surprise here, just a really basic Cosmos DB. So we could just natively store that. There is a storage account in the mix as well, where I am storing images like the one that you saw now, but I tried to choose some other ones, and we'll just arbitrarily choose some. And so what happens, oh, and then by the way, just to facilitate the invoking of my Logic app, I am making use of Event Grid because it's nearly free. And it does a really good job of scaling in the case that I'd be dropping a lot of images. And so basically, when I put a file, into this storage account, Event Grid picks up on that. Event Grid invokes, in this case, a webhook, which really is just an HTTP endpoint, HTTP trigger in this Logic app. I'll show it to you. And then this Logic app is going out to Cognitive Services. More fun to discuss there. Cognitive Services did great when it read the image. Reading the image was an adventure. And then basically over here, once those tags are extracted, we end up writing out a JSON document to, forgive my handwriting, to Cosmos DB. Okay, that's the gist of it. I want to say, yeah, that's all PaaS services. And oh, by the way, in the midst of all this, all of these things are one way or another going to be interacting with each other inside of a virtual network, which you may not normally do. If you are sitting on the PaaS side of the house, normally, you may not ever think about virtual networks, but we will. And that's going to give us the control to do things like applying our NSGs to deny internet, et cetera, et cetera, et cetera. So every one of these products has its own firewalling function to lock itself down. And I can also then lock down the environment in which they are communicating with each other. Okay, that's the gist. Let's dig into that.
Any questions on that before Sergio dives in?
Yeah, let me bring that back up.
Some folks might not know what a Logic app is, or necessarily what Event Grid or Cosmos is.
We're going to see all of it. So I'm going to walk us through it. But Logic Apps, suffice to say, is a graphical interface where you design workflows that look a lot like process flows that you might build in something like Visio. Except that instead of just having a process described by conditionals and steps, Logic Apps has, I think, over 500 connectors to other services, both Microsoft as well as third party, to allow you to either react to events that are happening in those services or invoke actions in those services. And so in this case, we're going to be via Logic Apps, we're going to be invoking cognitive services, which is our AI as a service. And we're going to be writing to Cosmos DB. And we're going to be reacting to event data that's coming from Event Grid, which is basically the eventing system that is basically flows through every part of Azure. And if you really needed to have that eventing system for your own purposes, you could even build custom events. I'm going to be using the part of Event Grid where Event Grid is aware of every event happening in Azure and can wire up an event to something to react to that event. And that something, in my case, is going to be the Logic app. Okay? We'll keep looking at it. We're going to see it. We're going to see it for real. So if I have left this in the state that I hope that I have, then I'm going to pop over. I am only using the VM out here that is in this VNet. That is in this environment. That in that virtual network I described, because I wanted to be able to kill the access to the internet. And so that's why I did this. But this virtual machine has nothing to do other than as a upload mechanism with what we're doing with the image. Okay. So let's start by finding an image. Zoo animal, how about farm animals? Come on, Google filtering, do me right. Okay, okay, we'll choose one of these. And I'm just going to save one of these images away. So the idea is that I have an arbitrary set of images. I'm just choosing one just for fun. And I'm doing manually what you certainly could be doing programmatically. I'm just going to go drop that image into a storage account. Now, the one I set up is this Azure user group 55555. And I'm going to come in here. There's an inbuilt storage explorer. If you don't have the desktop tool, there's an inbuilt one in the portal. And so I'm just going to use that as a convenient way to upload. And what I'm going to do then is I'm going to kind of put a pause on this one, and I'm about to upload the image. I'm going to set up another tab, because if everything is going the way that it should, eventually my Logic app should become aware of the fact that a new image has been placed out there. So I have a Logic app called Azure User Group Logic App. This is the preview version. So this is, you'll see a lot of things that look like app service. Well, because it's running on app service now. So I'm going to go to workflows, and this is where it'll start to feel more familiar. Demo is the one that I was working with. And in here, I should have a list. So right now, yeah, about 2 hours ago or so is the last one here, 10:21. If everything goes well, and I'll show you the wiring in a moment, if I upload an image here, then we should see, oh, back over here. Let's see if we see another succeed come up here or fail. We'll see. Okay, I see another succeed. Great. Now, this is just like Logic apps have always done, if you're familiar with them, we have an execution history. And so I'm going to come into the execution history, which is a really great way to see like what came to me, what happened. And so in this case, I received an HTTP request. And what it did was it came in and told me, this is Event Grid that called me. And Event Grid said, hey, you had a new blob uploaded. Okay, so let me grab that really quickly. Okay, I'll do new file, just for fun. Acting on the fly here. This is what Event Grid sent to me. It said, somebody put a blob in your storage account. This is the URL to that blob. There's that intro sheep. And that's going to be good because I'm going to hand that URL off to Cognitive Services. So great. Then I go and I basically initialize a variable, which I don't think I had to actually do anything with. Oh, I just created an empty string because I'm going to build up a document basically. Then what I did is for each file that was uploaded, now in this case I have it limited to one, but this could handle multiple. I'm going to call tag image, which is a cognitive services call. And so I'm giving the URL of this image that was uploaded to cognitive services. And when it comes back with this information. And so if I come back over here and just kind of cheat a little bit, this is what cognitive services thought about that image. It came back and said, well, I'm 99.9% sure I saw a sheep. I'm 99.9% sure I saw grass. It's outdoors. I'm getting a little less sure now as we go on. There were animals. They look like mammals. They were standing in a field, I believe. There might have been cattle in the background, maybe some livestock, but now we're getting down to like 93% confidence, 82% confidence. Maybe it was a goat. I'm 78% sure it wasn't a goat. And so on and so forth, right? Maybe I saw a dairy cow back there. And so I can take this data later on and say, well, I only want 95% confidence and above. But I now could go, and if I wanted to generate metadata for an arbitrary image, I did that, all of that, with what you see right here. 1, 2, 3, 4, 5 blocks on here in Logic Apps. I took the event that the image got uploaded, gave it to Cognitive Services, and then wrote that out to a Cosmos database, basically stored that same data basically in Cosmos right there. So it's not lost on me that it's become interesting that this use case has become trivial in terms of like how to do it. Like, yeah, you want metadata for an image, like that's super easy. Like we can go do that. But our purpose was to lock this thing down. Okay. So if I came out, and now I'm back on my computer. Okay. This is my computer on the internet. If I came out to the same resources that are being used there and I said, oh, I have another image on my computer that I want to upload, I could come into this resource group where everything lives. Actually, let me just do this from the storage account side because I have this blown up so big it's hard to see. So here's that same storage account where I should be able to upload arbitrary images. And here we go. I'm going to come to Storage Explorer so that I, nice web-based tool. Life is good. Kicking around, getting ready to go upload. And let's see. I think I have a grocery store we can do. Oh, let's see. And away we go. Great. I can do it from the outside as well. Okay. And so same exercise applies. Now, we don't have VMs in the mix, really. This is all PaaS services. But we go through the same exercise, and we could start with something as basic as this storage account. And so let me go and remember, we know how to lock down the storage account, right? If everything's wired up correctly, I should be able to limit the conversations that I want this to have. So if I come into networking, oh, sure enough, it's all, I'm going to refresh just to make sure. Yeah, it's all networks. I want to lock this down to the virtual network where everything lives. Oh, and here it is. 2 subnets in this user group thing. Great. Awesome. The Logic app default. We'll talk about this one in a second. This is amazing. So I'm going to go and lock this down. That takes effect. I come back over to my storage accounts, right? Because we wanted to, oh, I thought it was on the, yeah, it was on the right. So I'm just going to double check, make sure the networking went through. Okay, looks like it did. Let's come back in. I'm still on the internet right now. Let's come on through here, start to plow through once this, oh, now I can't do it. Okay, so I just locked down that storage account. That's one piece of the puzzle. That's amazing, but no problem. I have this challenge VM thing over here, right? I have this VM that's inside of my virtual network. So for my purposes, I can still do this. So I'm going to come back in here and I'm just going to upload zoo animals. I'm going to say it's okay to overwrite because it's already here because I used this once before. I'm going to upload it. Life is good. Let's go see the results. And so I'm going to come back to demo and I'm going to refresh this. and now we're failing. Well, what's up with that? If we come into the history, and again, Logic Apps is pretty nice about debugging this way. Now I'm getting a bad request on the cognitive services call. The cognitive services call is saying that image URL is not accessible. Well, what the what? I went in there and I created service endpoints for cognitive services for this virtual network. I did that ahead of time. I did all the things we were supposed to do. But when we are now working with PaaS services instead of virtual machines, we have one more thing to consider. When I had a VM in a VNet, okay, and I wanted to talk to, and that's probably a little gigantic, if I wanted to talk to an outside service like a storage account like we were doing, my traffic is going to do this. Dun, 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 dun. And as long as I can control this, and I can put a service endpoint here, right, so that this storage account knows about my VNet, life is good. I can also do the same for cognitive services. I can securely communicate over here. I can even lock down cognitive services to only accept conversations from this VNet via service endpoints. I could even go and place a private endpoint, which I did not do. I leveraged service endpoints for a reason I'll talk about in a moment. So when I did this service endpoint, well, then what's happening? Because now all I did was lock down this. But when I did that, I forgot about the fact that although I can securely invoke cognitive services, the same way we've been doing this all night, cognitive services runs in its own VNets behind the scenes that I can't even see. It's a PaaS service. There's a whole infrastructure I don't see. And the request to the storage account is coming from cognitive services world to the storage account. Because I gave cognitive services a URL and said, you go get the image. That's exactly what it's doing. And guess what? It looks like any other arbitrary service that's trying to access storage accounts. And it's not letting it. And that's why it's failing, because I totally locked that down. And so in addition to thinking about sort of the inside to out, with PaaS services, we also have to ask ourselves, how, if a cognitive service needs to reach out to another service, how does it do that? And in the case of the Logic app, my original plan was no problem. The reason why I chose the Logic app the way that I did is because it's built on app service plans or web apps, basically. And we know that for the longest time, App Service Plan has supported a feature called VNet integration. And what that means is that rather than all of the calls to the world happening from this mysterious platform as a service infrastructure that I don't see, that you don't manage, I can actually bring my outgoing conversations into the VNet and send them out from there. And that's amazing. That means that I can participate, I can send from Logic Apps, if I have to go talk to another service like cognitive services, I can lock down cognitive services to only accept traffic from this VNet, and I can make sure that my traffic is routed from this Logic app via VNet integration, so I become a member of this VNet, to then send out on this sort of approved path out. That's amazing. But not every PaaS service has the capability to perform like that. Now, you might say, with good reason, well, did you bother going and instead of using service endpoints, did you bother seeing if putting a private endpoint for cognitive services, that is giving it a real NIC, did you bother to see if maybe that would then create, route traffic that way? The answer was I couldn't. Well, why can't I? Well, I had other problems. I had other problems. One of the things that should absolutely be working in Logic Apps, and this is the preview version I'm talking about, is the fact that I should be able to establish a private endpoint inside of here so that I can, when we talk about event grid or other things calling it, Other things should be able to call this logic app without having to invoke it from the outside. I ended up using a service endpoint instead. And why was that? The minute that I enabled private endpoint, logic apps just broke. Just broke. And so I ended up in a situation where I had to say, okay, well, if I'm going to be using service endpoints, then great. And it was solving my problem for VNet in to out, but there's still some challenges to take on for the other. And so there's still challenges for situations like this where PaaS services are saying, well, that's wonderful about your VNet, but I call from my own. One of the other workarounds for here for what's broken right now is I also had the option of not passing it cognitive services a URL, but instead actually just passing in the image data directly. And then cognitive services would have had no reason to go and talk to the storage account, and that would have solved my problem. I didn't do it, but that's what it would have solved my problem. I highlight some of these challenges because there's two exercises in play. One, getting familiar with our options as far as how to make public PaaS services privately accessible in both directions. And two is starting to think about PaaS services a little bit differently than we sometimes do for situations like what we saw with cognitive services, where sometimes in an uncontrolled infrastructure, you have calls going out that you don't have a part of, right? So you can go lock things down all you want over here, but you don't have a part of that conversation. Now, most of the things that you would be using and invoking do have the ability either via service endpoints or via private endpoints to handle these things. But this is the kind of stuff that we have to keep in our mind when we get away from connecting a single service via service endpoint or private endpoint, and we start now trying to coordinate lots of them. And especially when we start to try to do this with nothing but PaaS services, no VM in the mix. So some things are the same. We still carry around that VNet, which we're not accustomed to, but those are some of the other elements that came into play in taking our sort of canonical demo of, image analysis and generating tags, and now starting to do what is necessary to draw all of those back in. Okay, so the next steps on this, as far as what I'm actually doing now, is one, I'm working, with engineering on this side to understand why private endpoints are causing failures on that side. And then second step to be to resolve this problem, because cognitive services does not have like a VNet integration feature. The two next steps is to test the behavior with a private endpoint in place. And if that has the same behavior where the back end infrastructure is making that call, then simply to feed cognitive services the binary data directly, which I do have in the Logic app. And then it won't have to interact with that service at all. And then everything is happy. So these are the kinds of things you kind of have to be on the lookout for and be navigating as you design this. Reality is, if PaaS services are a part of your strategy, but you also keep in balance concerns like compliance and things you may not have control over in terms of how you have to configure this from a network perspective, you have the tools. I was still able to accomplish what I needed to accomplish, but the kinds of things that you saw tonight that we walked through is some of what's involved in thinking about it the way that it is, and also planning for how to use those tools. So from a demo perspective, as far as what's on the rails, we can explore anything else you want to explore. We can do questions. A list of PaaS services that support VNet integration. Really anything based on app service. And so Azure Web Apps, I believe by extension static web apps, but that would be a little weird anyway because the code's not running on the server typically. Azure Functions for sure, because Azure Functions can run on top of app service. And now the new version of Logic Apps will also be built upon Functions, which is then built upon those. So those are the principal ones from the kinds of services we looked at tonight. Outside of that, many of the PaaS services or sort of the blended services do this by default. One of those, for instance, AKS. AKS is very much a blended offering. So AKS, it is platform as a service as far as the control plane is concerned, but you still are running actual VM hosts that do live in a VNet. And so they're still, those are still able to play and take advantage of any of these things that we saw tonight. So if you had, for instance, AKS and you had VM hosts and you needed to consume cognitive services in a private manner, you could do that today, and that would work.
I'll also add there's an integration service environment for logic apps as well. That would also do it.
Yes. Now, why? That's a good point. And so why was I excited to try logic apps? Because one of the things that you're getting just as part of this process of how logic apps is evolving is if I wanted to land logic apps privately in my own VNet before, similar to how we have an app service environment for the web app side of the house, we have an integration service environment, or ISE, for logic apps. But just like ASE, it's quite pricey. It's quite expensive. And for some use cases, and for people who made a big investment in logic apps, that's made a lot of sense, and it's been very successful. One of the really kind of neat parts about the new version of logic apps is that you're able to accomplish the same thing in terms of becoming more of a first-class citizen inside of this virtual network. But you're able to do that because of the capabilities of App Service Plan, or Azure web apps that have had that capability for now a couple of years at least. So yeah, no, it's good. Okay, any inside service pricing, component cost. Yep. So service endpoints, there's not a cost for. So when we're enabling service endpoints and we're basically having a routing influence on where things get routed, that's something there's not a cost for. For private endpoints, there's a twofold cost, and let me just pull that up from my other side. All right, let me clear out. Oh, I'm on the wrong monitor here. Delete. All right, so let's take a quick look. So anytime that we get asked this question, we use the same tool you do. So if we come back into private endpoints inside of this Azure pricing calculator, private link is the service really. And so there's two different components to the charge. So for every endpoint, you basically consider it up and running all month because you're not taking it down. So there's a 0.010 cent per unit hour on that. So that's this is all retail pricing too, doesn't take into account any discounts you might have. So $7.30 a month. These are all monthly as far as what one endpoint costs. Outbound data transfer is billed at the same per gigabyte pricing, and that adds up as such. And so, what the pricing is going to be is going to depend a little bit on the behavior pattern of what you're piping over that private endpoint. But that's essentially how that is how the endpoint portion of this service breaks down. Okay. Now, bandwidth charges do also apply. That is correct. But if you're careful to keep your private endpoints, your services, your endpoints, and your consuming service all in the same region, then that's generally something you don't have to worry about. If, however, you're crossing regions to get to that private endpoint, then bandwidth, as always, bandwidth then becomes a concern. If you haven't done the calculations on bandwidth recently or ever, ingress or data into Azure is never charged. It's data out where you have to look at it. So the egress is then what you look at in terms of bandwidth. All right.
I'll add my top tip for using the Azure calculator. Folks can sign, if you have an EA agreement, if you're a company with an EA agreement, you can sign in top right of that portal. And then at the bottom of the calculator, there is a drop down where you can pick the type of agreement, pick EA, and then you can see your customized pricing if you have any from the Azure calculator.
And I probably won't see it here given my kind of account, but
yeah, it's right there. Online services agreement.
Oh, okay, I do.
Pick EA, and then it'll pop up if you've got one and say, hey, If you have an agreement with Microsoft, it appears there. So top tip for seeing your customized pricing. Mike asked about cognitive service. Did you mention that you can put cognitive services in containers, Sergio?
You can for a limited set of them.
Right.
And so yes, you can. And we see that sometimes in IoT applications or sometimes in use cases where you just can't be cloud enabled. So yes, we have.
Yeah, I suggest that, right? Because that's, you can put those on a AKS cluster, which can be private and on a VNet. So again, as part of privatizing cognitive services, that might be an option.
I need to go through and test it out, but the reality is when we're landing something like that, that private endpoint, it's a service by service thing, but more often than not, the traffic is routing through that endpoint and out and around. So yeah, I mean that's the next thing that's sort of on my list to continue to work this through. When we put these together, generally speaking, they come from 3 buckets of possible places. Either we are putting together samples that are similar to challenges that we see some of you having. Sometimes we're testing out reference architectures for new services, which is a little bit more what how today happened. And now, like the mode I'm in now, is once I've now identified a problem, now I'm going to be doing repros and more formal setups on this to then send this feedback back to engineering on the Logic app side of the house, at least. So, that's generally where you see all these demos come from typically. And why Adam says at the top of the call that this is these kind of sessions are not the sales sessions. These are typically drawn from actual experience. Yeah. Real problems. Yeah.
The bleeding knuckles, suffering, And so Andrew in Australia had a question regarding he was asking why use Event Grid. Functional reason, like because Azure Bob, or because it's scalability and decoupling? Why Event Grid?
Scalability for me, because anything on the Logic app side where you say, well, wait a minute, I know Logic apps. I know there's a connector for storage accounts. And I know that one of the triggers is to fire a Logic app off when a new blob is uploaded. So why not use it directly? And you're absolutely right. That is true. One of the places, anytime you use a connector in Logic apps, one of the first places that you should go after you've kind of confirmed that the connector does what you need it to do is the limits section. And it's in the same place where you see triggers and actions. Look at the limits. And in the case of anything that responds to events within Logic apps, any of those kind of triggers, universally, and I'm trying to think of a counter example. I'll say almost, just so because we're recorded. Almost universally, those mechanisms are based on polling, and there are restrictions around throughput or number of pollings that can happen. And so, when I take something like Event Grid, I decouple myself because Event Grid is the eventing system in Azure. And so now I'm tied directly into the eventing system, and I'm not limited by that. So I'm doing real push. I'm not just doing polling. And I'm only now limited by my, in this case, my ability to invoke instances of Logic apps via an HTTP request, which is a much higher limit. And so if I'm designing this to be able to say, I'm not going to do onesie, twosie images, I'm going to do 2,000 of them, then yeah, I am going to try to take that into account up front and think about scalability in that way. So that's why I chose it, and why, unless it's just the right use case or my use case fits well within the limits, I tend to avoid any kind of polling-oriented triggers on the Logic app side.
Yeah, awareness of the limits that Sergio just highlighted, super important. I put the link in the chat. Everyone should be aware of all the limits all the Azure services has.
Yep.
Because it has them. You do not want to hit them without not knowing. I don't think I have any more questions. Any more questions? Anyone else? You know what, Sergio, could you show your Logic app in case folks haven't seen that? We saw it running, but it might be just for grins, fun and amusing to just show us what you built there. In case someone hadn't seen it. If anyone else has any other questions, still have a modest crowd.
All right. So this is the one that we used today. Again, if it looks a lot like app service, it's because it's running on it. But here's the familiar part: workflows and connections. So connections are the portion of information, the metadata that we store when you're connecting to external systems, in this case, storage accounts, cognitive services, and workflow is the piece where we do the actual work. Okay, so demo is where we're at. In the new version of Logic Apps, if you've been a previous user, one of the whole reasons of rebuilding this around functions is that just like with functions, you can do local development, and now you can do local development of Logic Apps. So well and truly, if you choose to look at it from a code perspective, this is the kind of code that would get stored in something like GitHub if you want to really manage this. The designer experience is here, and the designer experience is also now in Visual Studio Code as well as the ability to run Logic Apps locally via the functions runtime that you've had access to for a while on the Azure Functions side of the house. But at the end of the day, this is really what it's about. So in this case, my trigger was an HTTP request. If I come back out to the overview, this is essentially the URL that I use to do that. So great. So if I wanted to invoke it, I could do that. You can see it's long, and part of what you're seeing at the end is essentially the access key portion, so that not just anybody can invoke this. So once something is invoked, I'll get back into the designer here. Let me go ahead and minimize that so we can see this a little better. Once you have a trigger that basically kicks off this Logic app, then it's a bunch of actions in terms of what to do with it. And so in this case, I created an empty string, but then what happened is the request that was coming through might contain multiple entries. And so there's this for each loop, and that for each loop is based on the body. So it saw the body contained, and let me just show you, the body contained a JSON document, okay? And it said right away, it's like, oh, items and property, like there might be more than one of these JSON documents coming through. So when I went to use this the first time, it automatically created this for each and said, hey, based on the body, if there's multiple JSON documents that came from Event Grid, then you're set up to process them. And once I'm inside this for each loop, now, and it's a little small there, but it says items for each data URL. All of that sort of loop, logic and looping, everything it's accounting for, it's all being accounted for automatically. And so, for instance, I provided this image URL. And in Logic Apps, what happens is that all of the data from every previous step is available to you. And so in this case, I knew the URL was a part of the HTTP request that initially came. And if I scroll down, then I saw that somewhere in here, maybe it's at the top, maybe I missed it, oh, here it is, see more. I do this all the time, every time. Don't forget to hit see more if you don't see your variable, because it does choose just enough to kind of keep it on the screen. There's my URL. So in this case, that's all I had to do. String concatenation is super simple. You literally just keep adding things. You don't have to do any fancy functions. But now for this cognitive services call, it said, give me a URL, I'll go do my work. And then when I came down to build my JSON document that I was going to store in Cosmos, here's what I did. I said, it's a string variable. The value is literally typed in. I just typed in a JSON document. And when I did that, come on, I just typed in a JSON document, and everywhere where I had dynamic data, here's tags information coming back from cognitive services. It's this thing. So this is a JSON array. I just basically said tags. I'm sorry, that auto thing keeps popping up. And then I just included a URL as well. So I had an original URL back to the image where all those tags are associated with. And that was it. And then I just took that string, and because I didn't want to write a bunch of Cosmos code, I just connected to a Cosmos instance, told it what database, told it what container, told it the document, which was the string I just built, and that's it. That's all. So those 5 boxes respond to an event from Azure Storage. They pass that URL over to Cognitive Services, specifically a portion of our computer vision that generates tags. And then I take those tags, I build a JSON document, and then I send that document into Cosmos DB.
Thanks, Sergio.
Oh,
Does
yeah.
anyone want to see anything else from Sergio's demo, like Cosmos or anything like that?
I will say that button, Mike, is right here. So in Edge, yes, vertical tabs are my life now. So in Edge, if you see this top left button, you can toggle between horizontal and vertical tabs. Vertical tabs are amazing. I love them.
Yeah, I hadn't seen that either. I learned as well. So another day not wasted.
Also, if you haven't done it, not pertinent to Azure, since we're just talking about Edge for a moment, take a moment to actually try collections. It's really kind of taken over. I'll tell you one area that it's taken over for me is when I have got 14 tabs open, I go through and it's so easy to just come into one, say add current page, add current page. This is, if you come to the collection, then this right here, where are you? Just as I said that, right? Let me open up another one that has more than one. There it is. Open all. Oh my God, life-changing. I now just, I used to keep the browser open just like all of you did because now you had so many tabs open and this and that. Now, if I'm doing research on something, like I was doing a bunch of stuff around FS Logics, I can come in, hit open all, and away we go. Or I could send all of these links out to Excel, OneNote, Word. Collections has come a long way. Take a look at it. It's just my little, the Edge team will thank me for that. But it really is quite handy.
Sweet.
No problem.
All right. Any other questions or comments from anybody? Anything else anyone wants to see? Huh.
I feel your pain, Mike. Believe me, I feel your pain.
It's our life. Mm-hmm.
That's fun, though. I mean, if it's not fun, then...
That's what makes it fun. You have to enjoy change. I mean, you know,
yeah.
Otherwise, Azure's the wrong place to be. Or even the public cloud come to that.
Well, I know we had a ton of material to get through, but I really wanted to try to give a little bit of theory on service endpoints, private endpoints, see it in action, kick the tires on it, watch it happening. So hopefully, if it's only been terms that you've seen sort of fly across the wire, you at least got a little bit of look at what they are in action and some of the things you have to look out for.
Yeah.
Oh, great.
Oh, good. Glad to hear that, James. And awesome. Any feedback on this this Teams format for everybody? Is this any preferences over the Teams live stream that we've been doing? For those of you who have been to some of our previous meetups, Mike earlier commented that you preferred it. Do you like this more than the live stream events? Welcome feedback. I think this seemed to work pretty well. I think everyone's comfortable with virtual events now. Yeah,
I'm going to tell you, I've been a presenter in both situations, and even as a presenter, it feels so much more natural because in the live event, if you feel like as a participant you're a little remote to things, on the presenter side, it really does feel like you're just in a room alone.
Yeah, this is a lot more intimate. This is a much better experience. Yeah,
it is. Yeah, it's a little rough on both sides of it.
Yeah,
but
it is. You got to do the producing as well.
Yeah.
Yeah. Okay.
But with the spirit of what this group has always been, and I know that it's been so long since it's been in person. I mean, this has always been a collaborative group, and so I mean, as a presenter, I give it a thumbs up. It feels as a lot closer to what it used to be than I think we can possibly do right now. So.
Yeah. Thanks. And apparently people didn't have any technical issues getting in. That's been a concern as well. So that worked for everybody as well. So also good. All right. Well, cool. All right. Well, we're good. We're at time. So I'll thank everyone for attending, for giving up your evenings. Everyone in Houston and around the world, our friends over in Australia, a warm welcome for joining us. Thanks to everybody for coming in. We will again, as people were asking earlier, we'll be in person again. We'll do it. It'll happen in the meantime this year, I think. I reckon we'll be back in the Houston office, and perhaps we'll add virtual even when we're back in person, so that our friends around the world can see it. To answer the question, just came in the chat. Yep, I'll add the link to the video to the chat in the meetup. I'll put it in there so that anyone can review what you saw today, because there's a lot of content. And meanwhile, thanks everyone for joining. Everyone have a safe evening, and we'll see you next month. Thanks everyone.
All right. Thanks for your time.